Now we need to compare decimals. First we have 5.298 and 5.289. The way that we compare decimals is to write both numbers out, one below the other, with the decimal points lined up, because if the decimal points are lined up, then the place values, so the ones, tenths, hundredths and thousandths digits, will be lined up as well. Now we start by comparing the largest place values, so we work from left to right. Both numbers have 5 in the ones, so we go across to the tenths, but they both also have the same number of tenths, so we go on to the next place value column, so on to the hundredths. Now we can see that the first number has 9 hundredths and the second number only has 8, so 5.298 must be larger than 5.289. So now that we've seen that this number, the first number, has more hundredths, we don't need to look at the thousandths, because we need 10 thousandths in order to make something that's the same size as just 1 hundredth. Now we have 34.2 and 30.993. So our decimal points are lined up, which means our place values are lined up as well. And sometimes it's easier if we have empty squares, like we have here, to write zeros in those empty squares. Now we start by comparing the larger place values, which here is our tens, and both numbers have 3 tens. So we go to the next place value to the right, and the first number has 4 in the ones and the second number has 0. So we know that 34.2 must be larger than 30.993. So sometimes when we're comparing decimals, all we need to do is to compare what comes before the decimal point. So here we had 34 and 30, because remember, anything that comes after the decimal point is less than 1 whole. Now we have 1.405 and 1.44. Our decimal points are lined up, which means our ones, tenths, hundredths and thousandths digits are lined up as well. We can write a 0 in this empty square, and now we start by comparing the larger place values, which here is our ones. Both numbers have 1 in the ones column and 4 in the tenths column, so we need to go across to the hundredths. The first number has 0 in the hundredths, but the second number has 4. So 1.405 is less than 1.44. That might be confusing because 1.405 uses more digits, and with whole numbers, numbers with more digits are larger. But remember, we can put zeros on the end of decimals. 1.440 is the same as 1.44. All this 0 tells us is that we don't have any thousandths in this number. And if you put zeros on the end of decimals, so that you're comparing decimals with the same number of decimal places, it's much easier to see which is larger. Because we know that 1440 is larger than 1405, we know that 1.44 must be larger than 1.405. Finally, we have 2.9 and 2.099. Our decimal points are lined up. We can write zeros in empty squares, and we start by comparing the largest place value. Both of these numbers have 2 in the ones, so we go across to the tenths. And with this first number, we have 9 in the tenths, but with the second number, we have 0. So, because 9 is larger than 0, we know straight away that 2.9 must be larger than 2.099. It doesn't matter that the second number has more hundredths and more thousandths, because even 9 hundredths and 9 thousandths together is less than 1/10. Let's have a look at the numbers that we were comparing. First, we had 5.298, so that's 5 ones, 2 tenths, 9 hundredths and 8 thousandths, and we were comparing that to 5.289, so 5 ones, 2 tenths 8 hundredths and 9 thousandths. This first number was larger because it has 9 tenths, but the second number only has 8 tenths. Then we had 34.2 and 30.993. Now even though this second number has more place value counters, it's not as large as the first number, because remember, ones are larger than anything that comes after it. So even all of these counters together add up to less than 1 whole. Then we had 1.405 and 1.44. 1.44 is larger because remember, we need 10 thousandths counters to have something that's the same as just 1/100th, and this number has 4 hundredths. Finally, we had 2.9 and 2.099. 2.9 is larger because it has 9 tenths and 2.099 doesn't have any tenths. Even all of these counters taken together add up to less than 1/10. That's because we need 10 thousandths counters to make 1/100th, and we need 10 hundredths counters to make just 1/10. Thank you so much for watching. I really hope that was helpful. If you're a teacher or a parent, then please subscribe or go to keystage2maths.com to download resources for this lesson and many more. That's all for now. I'll see you in the next video.